It's a bit slow motion, but that's deliberate with a Wagon turntable. We'll take it in. With a bit of luck, it'll come out again as well. Right, I'll take the cover off. That's what it looked something like. It looked at the end. That's not this layout. That's another layout. Basically, the elements are obviously a turntable, which I'll have a look in a bit more minute, a tug with a very long coupling on it. And all that happens is basically when you start it going, the tug comes out, the arm on the end lifts, so that when the wagon rotates, clears the coupling. And then the coupling drops and drags it in. And the reverse is true. And the light you can see is a LDR, which just for positional purposes for the tug. That's the elements of it. Let's finish running. The Wagon turntable itself was one I built quite a long time ago. Basically, it's just a piece of PCB with code 40 rails soldered onto it. And I'll tell you, it's quite difficult getting those rails to sit at 90 degrees, 4.5 millimeters off center from the center line of the track. So that's the turntable. The tug is just a straightforward Kato chassis. I don't know whether you can actually see on that picture the bar that comes out at the end. Basically, this is what's called a DG coupling, which is there's a pivot on it, and there's an electromagnet uncoupler underneath, which just lifts that, and so that, and then that just runs up down on its own bit of track. I'll just turn over to another picture. Just bear with me a moment. Yeah, that's the underside, and on that you can see the light from a Uno, which is doing the dirt, all the hard work. On that, sitting on a interface board, you could call it a header, but it's underneath. And on that header, on that board, you've got two relays to control the direction of for the tug, together with a TBD chip to provide power for the relays. And then you've got three power chips, one 9-volt, one 5-volt, and one tip. This is a 102, but I usually use 121s, but there weren't any available, so I used the 102 instead, which provides the motive power for the tug. The relays are fed direct via the TBD from the Uno. It's not a Uno, it's a Nano, beg your pardon. But the traction for the tug is just basically a PWM output from the Nano through a 1K resistor straight into the base of the tip 121, and it runs off the 9-volt supply. The 9-volt supply is also used to feed the Nano, because I've been doing this a lot lately, which is to feed the Arduinos from a external 9-volt supply to reduce the load on the internal power unit, because it seems to get quite hot. And basically that's all there is. There are three servos you can see in the picture. The one on the yellow base is basically the one that sits underneath the turntable, and the other two are for the uncouplers. That's one of these efforts, which basically is a magnet, permanent magnet, on the arm of an Arduino, of a servo, which just twists round, and then there's a screw through the baseboard up underneath, and works very effectively as a coupling. Let me get that motor again. I don't see any better with this picture. It probably does show a bit better this. Basically, that's the DG coupling is this thing in the end here, and it's a modified one, and it just has this long arm, and you can pull down. Probably can't see it very well, but sorry. You can see the steel bit which is soldered to the arm, which just pulls it down. So when you get the uncoupler, that lifts to clear the coupling on the wagon, and then it drops. Oops, sorry, it just basically drops, so that bar at the end drops inside the coupling. And then it can just drag it and push it to and fro. And basically that's all it is. And the Arduino controls it and controls the two magnetic uncouplers. So really terribly simple. The difficult bit, which I did several years ago, was building that turntable, because that was quite an exercise. I think that was my second attempt at it, getting it done accurately, because in N-gauge it's 4.5 millimeters off center for the inside rail of the track, but it's fairly easy. You just do the two long lengths first, and then you do the two side arms, and then you start cutting. So you cut out, and then you've got two more bits to add at the end. It's basically just a bit of PCB with everything soldered straight on the top. I tell you this much: it took me quite a bit of time to get the positioning of the. Well, on the the piece of metal that comes down to act as the magnetic pickup, if you like, the bit that magnet attracts, that the length of that from where I position the magnet was actually quite critical, because you can get by using just a single light source onto an LDR, you can get a front and a tail end of the tug, but even that's not good enough. In fact, I think if I remember right, I put a slight delay in how before it shut off the power to when it's coming out, so I could just get the tug going a little bit further on, and then you position that dropper for the pick up the magnet, so it's just there, and you've got to be. And I've actually got you probably didn't see it, but there's a bit of a center. I've got a bit of cobblestone equivalent in the middle of the track, and that's partly there to prevent the magnet bar going down too far, because otherwise it ends up vertical. That just limits the action, and then you've got to work out how long that bar is going to be, how long the bar is to come out before you put the drop arm in. So all that interaction took me a few days to get that right, but the result seems to be satisfactory. Although I have had a bit of trouble when you first start up, that the tug doesn't always want to come out far enough. And I've been wondering whether to actually direct wire it with some wires instead of just relying on the track, but that's something to think about. Because it's fixed position, you could easily put in just a couple of trailing wires instead of relying on the track to rail conditions. That might make it a bit more certain that it'll come out and go back. And it's PWM output, so those Kato chassis seem to work all right with PWM, or even though they're cordless.
And you're using the 9 volts that drive in the Arduino to also provide traction to the tug. No interference issues or no problems?
No, I've got a 4.7 mic capacitor in there somewhere, I think, just to help it along on that 9-volt output. But no, I haven't. I was a bit surprised myself. But of course, you've got stabilized supply to provide the power for the Kato chassis. It's not going through any point work or anything else, and they're pretty good motors, these new air-cooled ones from Kato. And of course, once that 9 volts then feeds through itself through a power supply on the nano chip anyway, so it's sort of double protected in that sense. But no, so far, touch wood, I haven't had any trouble with interference on the nano.
Thank you. I love the idea of using a screw to transfer magnetic reluctance through the board. I think that's a great idea.
But I think someone on this group actually has done it elsewhere. But basically, yes, so you have 2 blocks to mount it on, and that is actually you can get these permanent magnets with a hole already drilled in the middle on a countersunk screw, and they come in the ones I got came in a tin box, so that with a sheath, with a piece of plastic to prevent it. Get it out, come out. Why do these things always go wrong when you want to demonstrate something? That's it. Basically, they come like that as the magnets, the hole in, they're countersunk, and you get the screws to go with them. And all I did was drill a pilot hole through the end of the servo arm, second hole in, and then once I got it in position, screwed it up. I cut off the surplus screw, and that is interesting because you have to be very careful with doing that because it gets very hot, and the plastic of the arm can melt, which makes for an interesting experience. Anyway, once you get the hang of it, you said, I think the last time I did 4 together, and I just sort of cut part way through on one and then moved on to the next. By the time I got back to the first one, it was cool enough that I could resume cutting. But yeah, that's quite an effective way of doing it. And for end gauge, I'm using 3mm wood screws, which I test for magnetic capability before I use, because I have come across some wood screws which don't have any magnetic capability. You've got to be able to, and then put them around flush with the baseboard, work out where you want to cut them off. You mark them at the top, unscrew them, cut them off, put them back in, bingo.
I take it that some of the screws will actually be pre-magnetized through their previous life before they get to you, and others will be incapable of being magnetized as well.
I think the ones I've come across, some which seem to be incapable of being magnetized. I don't know what they put in them these days, but it seems to nullify the effects of the iron.
For those that know, is there any chance that with repeated use of the magnet touching the ferrous screw that it could become permanently magnetized?
I believe there is a chance of that. It hasn't happened so far, but if it does happen, I'll just replace the screw.
Or presumably you could use one of these demagnetizer type things and stroke it in that way.
I think, bearing in mind the screw is totally buried in the wood, I think the easiest thing is just to replace the screw, to be quite honest. Because it doesn't.
Genius idea. Would that work elsewhere in your layout and siding?
Yeah, I'm using the same method of uncoupling all the way across the layout. Yes, it's basically a load of servos. And the beauty of it is you can use a servo 4 or a servo 1 and just have a switch, and you can leave the switch. In fact, actually, on that particular bit of the layout, I have got one which is done on the approach. If you bring a wagon in, the uncoupling magnet there is one of those 3 servos, and that's done from a switch off the little control panel I've got for operating this situation.
I love it. I'm so stealing that.
On a similar vein, Tony, I've not seen those permanent magnets with the holes in them before. Can you share your supplier?
Not off the top of my head. I went on either Amazon or eBay, and I can't remember which.
Okay, sir, no problem.
And you just asked for small magnets. I can't remember actually what I asked for you, but you sort of then come across these ones which are pre-drilled and.
Anthony,
I found some on Amazon a couple of days ago, and they came in the post yesterday. You just search for magnets on Amazon.
Cool. Thank you very much.
You'll find also a whole raft of
square magnets, round magnets,
squares, round, the whole
gamut of them.
Fantastic. Thank you very much, guys.
Ron, use a question.
Okay, yeah, I'm just wondering about how the magnets are, the magnetic poles are situated on the actual magnet. Are they sort of end to end, or are they? And
it seems to be through the middle. I don't know how they've done it, but have I got something? Yeah, it just seems to be straight through the middle. I mean,
so I'm just thinking of the magnetic path of when it goes up against the or up near the wires
it just sits down like that.
Just pull it. Oh, okay, so it just attracts it, doesn't it? It's not
just attracts it.
Yeah,
and then transfers the magnetic path into the into the rod, the
Yeah.
screw.
Yeah. Okay. Yeah. That's fine. I just wondered if you can get it any other way. You know, sort of if you order the magnets, are they going to? Can you get them polarized in a different way? In which case, it could be a problem.
Well, I don't know. It's a short. I mean, presumably it's easier to put. I don't know, because being circular,
Yeah.
how else would you? I mean, you'd have to have them opposing poles on either side of a circle, which is not
I
very
know.
clear.
Yeah. The Sod's law says that you're going. That's what you're going to get.
Also,
But
the
then it
fact,
might not. Yeah.
see,
because
also the
with this-
fact that they all come stacked together means that they're all of identical polarity.
Well, that's a start, isn't it? Yes. Yeah, because they come in a great big, as you saw.
Yeah.
I mean, that's 2, 4, 6, 8, 10, about 11 or 12 magnets in there. And they just, that's the, can't really
Yeah.
see it.
If it was from end to end, then rotating them on there wouldn't make any difference. But if it was
No.
from side to side, rotate them and they'll spring off.
Yeah, no, I'm rotating them.
Yeah.
So-
Oh, well, that's proven that. That's fine.
So you never know what you're going to get sometimes when you do it online.
Yeah, I know.
Tony,
Yeah.
did you say that you had 2 LDRs to detect the bogey get back and forward?
One LDR and one light source. Let me go back onto that. Let me go back onto the that's the one. Yeah, there we go. Yeah. Basically, there's an LDR, there's an LED on one side and an LDR on the other side. If I just power it up, you can see the light coming on. Right, the thing goes through, and once it's cleared the rear, so I've got an LDR that side and then an LED that side. I put them inside boxes to reduce any effect from light all the way around. I mean, it's just, that's it.
I was just wondering whether your suggestion earlier about having like a threaded rod would be more secure to get to you don't see the tug anyway, do you? So
No,
and it would mean you wouldn't have things like the local being stuck and have to be the finger of God to move on occasion.
yeah, it
more-
doesn't do it very help.
More
I've had a
reliable.
look, yeah, I've had a look at a variety of things. The problem is there's quite a long length. You've got to move it over. I haven't found any better method. I've tried various things. The thing is, with 2mm, the track gauge is only 9mm. It doesn't give you a lot of room to do anything with, if you like. And those Kato chassis seem to be extremely reliable. I've just got to watch make sure everything's clean when I start.
It's funny, if you'd asked me to solve that problem, I would have thought about stepper motors and belts and all sorts of things. The last thing I would have thought about would have been a Kato chassis and a piece of track.
Well, when I first did it, the first time I did it, I actually used a servo with an arm on it, pulling a wagon backwards and forwards inside, which is sort of that, and that was very unsatisfactory. So once I got my hands on those Kato chassis are fairly new. They haven't been out that long because they're sealed motor. They're totally sealed. They seem to be extremely reliable so far anyway. And all right, I'm using PWM, but it's not very, it's only about, I'm only using about, I think it's 5 volts it comes out at on the track. So it's not on a 12-volt motor, so it's not a great, and the power rate load is very limited really when you think about it. That's one Wagon.
Another way of doing it would be to use the sort of thing you get with robotics, which would be a stepper motor and a lead screw and nut, and it's the nut transfers the drive, and that way you can set up distances fairly accurately, and you could run it from your Arduino in the same way, in a similar way to where you've been doing it, I think. Yeah,
I haven't been playing around with that sort of stuff, so it was not on my, it wasn't in my picture, if you like.
It's a bit like Chick, isn't it? He wouldn't have thought of using a Kato. You wouldn't have thought of using a lead screw and stepper.
No. Yeah. And in fact, until I got my hands on these new motors, I wasn't quite sure what I was going to do. So I could easily have ended up with stepper motor and a lead screw and everything else as an alternative method.
Either way, Tony, it's a very nifty little piece of kit. Thanks for the
Yeah.
inspiration.
Yes. If anyone wants any further information on the software, let me know.